Hello everyone, this is Mrs. Ruscio and you are watching the Factoring Trinomials Day 2 Notes video. In this video, we are going to continue what we talked about in Day 1 with the Factoring Trinomials, only we are going to spice things up a bit. And instead of only factoring when the leading coefficient is a 1, we are going to see things like 2x squared or 3x squared, so something different than 1 as a leading coefficient. So let's dive in. Number 1 gives us the graph of f of x is equal to 2x squared plus 7x plus 3, and it's asking us to find the roots. So the roots, well, one of them is really easy to find, and the other one, not so easy, and I don't want to estimate. I mean, it looks like it's at negative 1.5, so I'm just going to write x equals negative 3 and x is equal to, I'm not exactly sure with this one. Okay, so what we are going to do here is the box method, and we're going to see how there's some similarities and some differences to what we talked about yesterday. So you know the drill. 2x squared goes in the top left box, plus 3 bottom right, and in this little corner up here, plus 7x. So we are trying to find two things that multiply to 2x squared. Well, we know that x times x is x squared, but 2x times x is 2x squared. So right away, I'm noticing that there's something different. And what's going to happen is that will change what's in this box down here. Okay, so we also need two numbers that multiply to 3. Remember, we always want to find the multiplying first and then figure out the addition, which is this 7x up here. Okay, so 3 and 1, I think, are the only two numbers that multiply to 3. And the good news for me is that all of these are positive. So I'm going to put the 3 here and the 1 here. And let's do a guess and check. 2x, and then x times 3 is 3x. Oh no, 2x plus 3x is 5x. So what this just told me is that, well, some of you might think that the numbers are not 1 and 3, but they have to be 1 and 3. The trick here with questions like these is that you can flip around the numbers and put the 3 here and the 1 here, because this 2x term there can change what happens in this box down here, which is different than what we talked about yesterday. So 2x times 3 is 6x, through x times 1 is 1x, 6x plus 1x is 7x. Oh, happy day. So my final answer is 2x plus 1 all times x plus 3. All right, let's see this again in action with a different question. Number 2. So we have 2x squared plus 9x minus 35. You know what to do. 2x squared goes here, plus 9x up in this top corner, and then minus 35. Well, what times what is 2x squared? If you said 2x times x, you are correct. And then let's think of some numbers that multiply to 35. Obviously, 1 and 35, 5 and 7. Maybe let's try those. So the one thing that I'm noticing here is that we have a negative here and a positive here, which means that my numbers have to be opposite signs. Okay, and the larger value when adding has to be positive. So I'm going to try the 7 here and the 5 there. Let's just try it out. So 2x times 7 is 14x. 5 times x is 5x. But the problem that I have right now is that it's a negative 35, and right now I have both the 7 and the 5 as positive. So if I make this negative, 14 minus 5 gives me that positive 9x. So there's a lot of guessing and checking and a lot more variation to these types of problems. If this hadn't worked out, I would have probably tried flip-flopping my 7 and my 5, which we didn't have to do yesterday, again, because we didn't have this 2 in front kind of messing with things. All right, now number 3 looks a little different because it's a binomial. So if you think back to what we've been doing, let's just go ahead and fill in the box. So 4x squared we don't have the x term, so we're going to say it adds to 0x. And in the bottom right, it's 25, minus 25. So to me, this is another one of those special kinds of questions where the sides of the boxes should be the same, just with the opposite sign in between separating the two terms. So 2x times 2x is 4x squared. 5 times 5 is 25, but remember, one of them has to be negative. So let's check this. So because this was a binomial, we're going to use a special trick that we remembered, where we have 2x times 2x, 5 times 5, one of them is positive and the other one is negative. Let's see how this works in the box to make sure that it's true. So that's negative 10x, that's positive 10x, that equals 0.